Perfect list, yes. Like we mentioned before, understanding what each of your attributes is, how it's meaningful, and who finds it interesting is going to be a key to all data visualization. And you can come up with completely different target audiences to who is interested in what, to figure out whether you want to emphasize, MPG versus cost, or MPG versus consumer rate. If you're trying to figure out, okay, what are Americans? I'm assuming these are Americans. What are most Americans interested in? Then you might want to correlate consumer rate versus price, and consumer rate versus miles per gallon. And if you find some correlation, you say, oh, apparently Americans care more about MPG because the ones that have the lowest MPGs, those are the ones the car people are most excited about. Or maybe it's price. But maybe it's not that. Maybe it's where the company comes from. Maybe it's overall cost. So depending on who you think what you're trying to accomplish, what the audience is how you're going to tailor the visualization and the truth that you decide to bring up. So that's very important. But now we come back to representation. And that's probably the most important part of the overall class in the next 10 weeks is this next part, is how to represent data. And basically this is something that we're going to quiz you basically every time that we come into class, is how to represent data. What are your different data ways to actually represent data? So just like we said before, data visualization is about putting data into a more understandable form, right? This includes the whole fat process from acquiring the data, cleaning up the data, which is what you guys just did, right? You acquire the data, you clean the data, you might have to filter it. If it wasn't top 100, you just want the top 10. Or if there's something weird, you might want to get rid of it. All of that is actually part of data visualization. And unfortunately, I can tell you by experience, sometimes this is more than 50% of your job is just battling the data. It could be. Hopefully we don't get into that this term, but it could be. Then it all comes down to this middle part, representation. How are you going to present the data? And then the next part that we're going to talk in 3 weeks is probably how you interact with the data. But let's start with the representation. How do you actually represent the data? So it turns out that there's this thing called encoding channels. So there's no marker. So there's all these encoding channels in ways we can actually represent the data. One of the most powerful ones is actually position, where you place the representation for the data set, for each of the data records, right? So like we saw all the Kepler stuff, like we saw basically every single thing that we saw actually places each record in some specific part of the screen, whether it's around the clock, whether it's actually in an XY axis, whether it's actually showing you one thing at a time. It all has to do with position, where you're putting it. So automatically we have position as one of the ways we can encode data. The second one, and the one that's probably the trickiest to use, is color. Now I've decided to actually split it between hue and luminosity. So hue, all you guys know Photoshop, so you know if you do HSV, it's just where in the color wheel you are, versus luminosity, just how bright or dark the color is. You as graphic designers, or designers I should say, you as designers actually understand the whole power of color and how luminosity, contrast actually makes a huge difference in the way we understand and we see information. In data visualization, that gets ignored really quickly. And the reason it gets ignored really quickly is because you're trying to transfer data, numbers, into color, right? So usually when you punch in a color, like you punch a color in Photoshop, what do you usually punch in if you actually type in something? What values do you usually put in? What does values usually look like?
Like a number, an integer?
It's usually an integer, and usually a collection of what kind of integers. Like how do you specify? Like blue, we can say blue. How would you actually, if you're punching it in?
RGB values.
RGB values, right? So the way computers understand color is by splitting it into red, green, and blue, right? Which are not even the primary colors, right? That's just the way LEDs were made and color vibrations to actually be able to do this. So because of that, there's a lot of work actually being converted into just weird RGB projections, which is not really what we want to do. We want to do more of hue and luminosity. And we're going to have a whole lecture on color next week. Now, again, from your intro to graphic design classes, we become really good at understanding how lines can be.
You said we're not sure next week, but Monday class.
I mean, yeah. So line and line length and line width, those are actually visual attributes that we are actually more accustomed to use when you're actually doing illustration. They can actually convey quite a bit of value, but again, it all comes down to order of understanding. Okay, so when you see something, how quickly do you actually understand the thickness or width or length of a line? And we'll talk about actually the cognitive preferences when it actually comes to actually understanding this data. But it's one of the data encoding channels that we have available to us. Two more, scale and orientation. Again, the Kepler example was a really good example. When we had planets that were bigger in size, we actually used circles that were bigger. So scale is a really good way of representing data. The other one is orientation. If you have an object that when you move it, you can actually tell where it's going. Orientation can actually be really good at encoding data. Versus imagine when you Uber, if you see your little car going away from you versus going towards you, it gives you automatic information as to how long probably it's going to take to get to you. If the guy's going the wrong way, you say, okay, so obviously we're roundabout. So orientation can actually be quite powerful in showing information. Then what we're talking about is the different attributes. Remember when we showed the top 10, you had different columns. All of these things can actually be mapped to each different of these things. They can be mapped to color, they can be mapped to position, they can be mapped to orientation. They can be mapped to shape, right? So for instance, when you're showing countries, you could say all companies that are from the US are going to be circles. All companies that are from Germany are going to be little squares. So you can actually map data to shape. Notice that now we get it again from your graphic design days. Occlusion. If you have objects in front of it, how easier to understand. If we have shapes occluding each other, how easy are those going to be to understand? Similarly, we have motion, and we're getting a little bit not quite into the interaction mode. We actually see something moving in time, but simple things like things vibrating or rotating, right? Our eyes are really good at, if you see an ocean of things static, the one thing moving, your eye can be drawn to that. So motion can actually be quite powerful, especially if you're trying to highlight a certain thing. If everything's in motion, that'd be a little more difficult. The last two start getting more in the idea of layering information, right? So when you have a visual element, it can have position, it can have color, it can have orientation, it can have shape. But then on top of that, you can add extra attributes on top of it. You can start layering information on top of it. So the most obvious ones that we have are markings, whether you do an X through it or have little hash lines, little kind of coming out to it. Enclosure is a really good way of showing extra information. So for instance, if you actually put all these four, you put a line around them and you're saying, okay, all these four belong together. So enclosing information can be a really powerful way of showing hierarchy. And we talked about hierarchy a little earlier. Even those small cartoons actually show that information. So how hard is it to actually do the visualization and start using any of these attributes? And the answer is actually not terribly hard. Hey, it's a phone. So I love showing this example of, it's an art piece by this guy called Evan Ron. He did it quite a while ago. But he was actually flying coast to coast, and all he had in front of him was a Skybound magazine. Have you guys ever seen the Skybound magazine? It actually went out of business like 3 years ago, so it's a really outdated example. It's kind of fun. So what he did is he actually ripped out the face of the person in the front of this kind of magazine, and then he said, you know what, let me go through the whole magazine and rip out every face that I find. And let me just lay them out in front of me, in front of my tray. And he said, okay, let's arrange them. Let's put them together. So here's him arranging all these images by, well, you tell me, what are they arranged by? By size, right? So you have, so right now, what of the encoding channels that we just talked about, and again, we're talking scale, orientation, enclosure, color, position, motion, what encoding channels can we already kind of see being displayed here? Scale, orientation, right? And this is what orientation are they in?
Linear.
Kind of. So when we're talking about orientation, we're actually talking orientation of each individual object, right? So now they're all oriented pointing up, right? Because that's what we expect. You don't expect upside down heads. So there is orientation, but there's a layout, right? There's a very explicit layout, and it has kind of this kind of growing from left to right. So you said scale, right? What else do we have? Shape. So there's the actual shape of the cutouts, right?
Well, the position.
The position, right? And the position is related in this case to the size, right? So he automatically, purposely chose in this case, the x-axis to say, okay, put the smallest things on the left, the biggest things on the right, and how about the y? Is that actually encoding any information? Not an explicit information, right? He just came up with something that kind of has this growing look. He could have tried to make it a little more square. It wouldn't be as fun. So there's a bit of just trying to tell a story to this picture, right? Now this doesn't tell too much of a story. Let's look at different one. Can you tell what these are?
Men and women.
Men versus women, right? So now the position is pretty simple, right? We're using men on the left side, women on the right side, right? So it's not a continuous x-axis, it's just one side or the other side, right? A bit of layout, a little spacing. Is this starting to tell a story? So what's this telling you about Skyball magazine?
Their like target user is more towards women.
So the target user could be women, right? Or it could be that they believe that women sell more stuff than men. So it could be somewhere in that idea, but it's already kind of hinting at a story. So now we have data visualization, encoding channels, there's still orientation, there's still size, there's still this information, but now it actually starts telling a story. And it's exactly the same data, right? And the cool thing about the representation of the data is that the representation of the data, in this case, is the data itself, right? Like in your Game of Thrones example, if you actually use the picture of the character that got killed in season 7, it's bolded for everybody, you actually show it there. How about this? Close. A little higher.
The hair color.
Hair color, right? So this is showing hair color. So now Evan decided to align them left to right using hair color. Now the fatness of the shape is a little weird, but I think in this case he's trying not to emphasize any particular hair color or be obvious about any story, right? He's just saying there's just a variation. So there's a little less of a story, but by showing this amorphous shape, he's purposely not calling attention to the number of blonde people versus the number of redheaded people versus the number of brunettes versus the number of dark colored haired people. So it's as a designer, he chose what to show and how to show it, right? In this case, it's not telling much of a story, but that's on purpose, right? He could have tried to actually tell a story more about hair color, and I don't know what the story would be. You might have to remember, like we said, derived variables. We started with this was the ranking this year, that was the ranking next year. So the growth of things. They could be the same thing. How many of these people have black hair? How many people have blonde hair? It's something, edit extra characteristics, start kind of doing some data analysis on the stuff to actually be able to bring in new variables that you can map to this. How about this one? Can you tell what that one is?
By race.
By race. Yeah. So that's probably the reason we didn't know this. That's I'm sure it's just because people were not paying attention. So this is all of a sudden tells a much bigger story, right? Dark colored people versus light colored people. So now this tells a very massive story. And again, the data representation is the same data object, same data representations as before, but the positioning is just according to a different encoding channel, right? Sorry, a different variable. The encoding channel in this case is horizontal position, which he used the most, but in this case, race is the attribute that he's trying to encode in with the X position. And that actually tells a very meaningful story, right? And very interesting. Now we don't know what goes from there, but already kind of start saying, okay, what can we ask of this information? What's interesting about it? By looking at it, what do we learn? So this is a really awesome example of how easy is it to visualize and to show something and to represent something depending on what we're trying to do, which is your next exercise. So your next exercise is to come up with 2 different visualizations for your top 10. Okay? And the way you're actually going to visualize it is by playing with tic tacs. So I brought a bunch of tic tacs. They actually come in 4 different colors. And what I want you to do is, I want you to think of 2 personas, or 2 audiences, 2 people that would be interested in the data that you have, and then say, if that person was interested in my data, how would I represent it? How would I lay it out to actually bring something about the data out? Again, as long as the truth is out there, it doesn't matter if it's an amazing story or just they all make the same amount of money. They will all be just as meaningful. Or it could be, wow, this one thing was much more meaningful than others. Okay? So I want you to come up with 2 different approaches and come up with 2 visualizations, take a picture of them, and then put it on Dropbox. Okay?